Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 2, May 2021. If you find this video is helpful, please don't forget to subscribe and let your other friends know about my channel to support me. And let's get started. Iron may be extracted from iron 2 sulfide FeS. Outline why metals like iron can conduct electricity because it has delocalized C of electron. So these are the positive charge and all positive, and then in between this it has electron that delocalize. So we can say that it's a delocalized C of electron. That's why metal like iron can conduct electricity. Justify why sulfur is classified as a nonmetal by giving two of its chemical properties. Because sulfur able to form acidic oxide. Okay, for nonmetal, it will form acidic oxide, and for aluminum, it will be amphoteric. And for metal like group 1 and 2, it will form basic oxide. Also, it able to form anions. For non-metal, able to form anions. For metal, forming cation, a positive ion. Also, it able to form covalent bond with other non-metals. So you can choose two from these three because it's 2 point. Sketch the first 8 successive ionization energies of sulfur. Electron configuration of sulfur with the number of electron is 16. That would be 1s2, 2s2, 2p6, 3s2, and 3p4. So it has 6 valence electron. Therefore, for 6 electrons right here, should be a bit closer, or they're close to one another. And for 5, maybe we can go up a little bit. And for 6, a little bit right here. So at least it should be close to one another. Okay, and for the 7th ionization energy, that should be jump, and for 8 also. Okay, so there should be a large increase when changing energy levels, because now we goes to the 2s and 2p6. So changing the energy level should have a large increase. Okay, so 2 regions of small increases and a large increases between them, between 6th to 7th ionization energy. Iron 2 sulfide FeS is ionically bonded. Describe the bonding in this type of solid. Ionic bond. It has electrostatic attraction between oppositely charged ion. It's between Fe2 plus and S2 minus. Okay, metal versus non-metal. State a technique that could be used to determine the crystal structure of the solid compound. It's X-ray crystallography. It can also help you to predict the bond length and also bond angle. State the full electron configuration of the sulfide ion. Sulfide ion, that would be S2 negative with the number of electron or proton number 16. So now the total of electron will be 18. So the electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. Total is 18. Outlined in terms of their electronic structures, why the ionic radius of the sulfide ion is greater than that of the oxide ion. Oxygen with the atomic number 8 and the charge 2 minus becomes 2, 8. So now total electrons are 10, so 2 and then 8. For sulfide ion, 16, 2 minus, because it gains 2 electron and it comes from group 16. So that would be 2, 8, 8, because now the number of electron becomes 18. So as you can see here, it will have 2 shells, and this one it has 3 shells. Therefore, electron further from nucleus or sulfide ion has an extra shell. That's why the ionic radius of the sulfide ion is greater than that of the oxide ion. Suggests why chemists find it convenient to classify bonding into ionic, covalent, and metallic, because it will allows them to explain properties of different compound or making prediction. For example, if it's Na plus and Cl minus, it will soluble in water. Or covalent bond like ethane, it will have a low boiling point. So that's why it's easier for chemists to classify bonding into ionic, covalent, and metallic, because it will have a different properties and they can predict what will happen to this compound that has ionic bond or covalent or metallic bond. The first step in the extraction of iron from iron 2 sulfide is to roast it in air to form iron 3 oxide and sulfur dioxide. Write the equation for this reaction. So if it's in air, it must react with some gases in air, right? So the equation, that would be FeS, solid, react with some gases in the air, produce Fe2O3, because this Fe2 plus and S2 minus forming Fe3 plus O2 minus. So crisscross will be Fe2O3 and SO2, because it will produce sulfur dioxide. Okay, so as you can see here, the products contains only oxygen. Therefore, some gases in air, it's oxygen. And now you balance them. That would be 4, 7, 2, and 4. Deduce the change in the oxidation state of sulfur. The reaction just now is FeS plus 7O2, 2Fe2O3, and 4SO2. So this will be -2 because it comes from group 6, gain 2 electron, and that would be Fe plus 2 for Fe. And for this one, -4, S will be plus 4. So you can answer from -2 to +4, or the change will be +4 minus -2, that would be +6. Either one of these answers are correct. But be careful, for this part, you cannot do 2 negative and 4 plus. That would be wrong. Suggest why this process might raise environmental concerns, because it produces SO2, and SO2 can cause acid rain when it dissolves in the water. Explain why the addition of small amount of carbon to iron makes the metal harder, because it disrupts the regular arrangement of iron atoms. It prevents layer of atoms to slide over one another. Okay, let me explain. If it's only iron, the arrangement will be regular, and metal has a properties which is malleable, can be hammered into a shape, because this layer can slide over one another. Okay, because the radius of each atom is the same. But this case for iron, imagine if adding carbon, so the atomic radius will be different, okay, because it's not regular anymore. Just let's say the big size are the same, iron, and then the small one is carbon. So it has a different ionic radius or different radius, so it will stop layer from sliding over each other. Therefore, with carbon will be stronger compared to only iron. Iron 2 sulfide reacts with hydrochloric acid to form hydrogen sulfide H2S. Draw the Lewis structure of hydrogen sulfide. Predict the shape of hydrogen sulfide molecule, band or V shape. In aqueous solution, hydrogen sulfide acts as an acid. State the formula of each conjugate base. Hydrogen sulfide, when it reacts with water, it will form HS minus and H3O plus. H2S will donate proton to H2O, so it will act as an acid, this one as the base. Therefore, this one it's conjugate base and this one it's conjugate acid. So conjugate base of hydrogen sulfide is HS minus. Saturated aqueous hydrogen sulfide has a concentration of 0.10 mole decimeter cube and a pH of 4. Demonstrate whether it's a strong or weak acid. The concentration of H plus is 0.10. So pH will be negative log 10 to the power negative 1, which is 1. So this, if it's 1, should be strong acid, right? But the pH is 4 with this concentration. Therefore, it is a weak acid because the pH is 4 and it is a weak acid as pH is high. Calculate the hydroxide ion concentration in saturated aqueous hydrogen sulfide. pH it's 4, so POH 14 minus 4, which is 10. Concentration of OH minus would be 10 to the power negative POH, which is 10 to the power negative 10. A gaseous sample of nitrogen contaminated only with hydrogen sulfide was reacted with excess sodium hydroxide solution. at constant temperature. The volume of the gas changed from 550 centimeter cube to 525 centimeter cube. Determine the mole percentage of hydrogen sulfide in the sample, stating one assumption you made. Mole percentage of H2S would be volume reacted divided by initial volume times 100. That would be 550 minus 525 divided by 550 times 100. You will get 4.5%. What about the assumption? Both gases behave as ideal gas, nitrogen and hydrogen sulfide. Ideal gas rules are they do not repel or attract each other, they move very fast, they have no volume themselves, and they do not lose kinetic energy when they collide. So these two show the behavior of an ideal gases. Magnetite Fe3O4 is another ore of iron that contains both Fe2 plus and Fe3 plus. Deduce the ratio of Fe2 plus ratio Fe3 plus in Fe3O4. Okay, so the reaction would be FeO react with Fe2O3 will produce Fe3O4. So for the oxidation number here, it's +2. This one -6, but for one Fe only here, it's 3. So Fe2 plus, it has one Fe2 plus and it has two Fe3 plus. There are one Fe2 plus in FeO and two Fe3 plus in Fe2O3. Therefore, the ratio would be 1:2. Iron exists as several isotopes. State the type of spectroscopy that could be used to determine their relative abundance. It's only mass spectrometry. State the number of protons, neutrons, and electrons in each species. The protons will be 26, neutron will be 54 minus 26, which is 28. Electron will be also 26 because it is a neutral. And for protons here also 26, and for neutron that would be 56 minus 26, which is 30, and electrons because 3 plus, so lose 3 electron, so 26 minus 3 will be 23. Iron has a relatively small specific heat capacity. The temperature of a 50-gram sample rises by 44.4 degrees Celsius when it absorbs 1 kilojoule of heat energy. Determine the specific heat capacity. So that would be C, Q divided by M times delta T, which is 1000 joule divided by 50 times 44, and you will get 0.45 J per gram and Kelvin. A voltaic cell is set up between the Fe2 plus and Fe. This will be oxidation. And Fe3 plus and Fe2 plus, this will be reduction. Deduce the equation and cell potential of the spontaneous reaction. Use section 24. So the equation, the first one will be Fes becomes Fe2 plus 2 electron. Okay, because it is oxidation. So between this is oxidation. Oxidation lose electron. So that's why we start with Fes. The second one, Fe3 plus, is a reduction. Fe3 plus, Fe2 plus, this is a reduction. so gain electron. Therefore, it will be Fe3 plus gain electron, 1 electron, becomes Fe2 plus aqueous. Then we need to multiply by 2 because here is 2 electron, here is 1 electron only. So that would be, this will stay the same. And for this one will be 2 Fe3 plus 2 electron becomes 2 Fe2 plus aqueous. So we can eliminate this and then we add this. That would be Fe solid plus 2 Fe3 plus aqueous becomes Fe2 plus aqueous plus 2 Fe2 plus aqueous. What about cell potential? That would be reduction minus oxidation. So reduction would be Fe, which is plus 0.77 when you check on the section 24, minus negative 0.45, you will get plus 1.22 volt. The figure shows an apparatus that could be used to electroplate iron with zinc. Label the figure with the required substance. We have iron and zinc. Zinc is more reactive compared to iron. Therefore, zinc will experience oxidation and iron will experience reduction. So if it's oxidation, that would be anode, and reduction, that would be cathode. Okay, anode will be positive and then cathode will be negative. Okay, panic. So positive anode, negative cathode, and anox, cath, red. So anode always oxidation, cathode always reduction. So this one will be iron because it's a negative reduction, iron, and this one will be aqueous zinc salt or Zn2 plus, and this one anode will be zinc. Outline why, unlike typical transition metals, zinc compounds are not colored because it has a full D shell because it's 3D10. If you try to figure out the electron configuration of zinc with the atomic number 30, 3D will be 10. So it's a full D shell. Therefore, zinc cannot form a color compound. So it's not very typical transition metal. Transition metals like iron can form complex ion. Discuss the bonding between transition metal and their ligands in terms of acid-base theory. Ligand has a lone pair. Therefore, ligands are acting as a Lewis base that donate pairs of electrons to metal ions, forming coordinate bond. So metal ion is a Lewis acid because it accepts pair of electron, but ligands is acting as Lewis base because it has a pair of electron that will donate to the metal ions. Hydrogen peroxide can react with methane and oxygen to form methanol. This reaction can occur below 50 degrees Celsius if a gold nanoparticle catalyst is used. The diagram shows the Maxwell-Boltzmann curve for the uncatalyzed reaction. Draw a distribution curve at the lower temperature and show on the diagram how the addition of a catalyst enables the reaction to take place more rapidly than a T1. So T2 is a lower temperature. When the peak is lower and slightly to the right, it means that peak is for higher temperature. Therefore, the lower temperature should be a bit high. And okay, it should be like this, okay? And this, please don't touch the x-axis, okay? So you can just make it nice, okay, like a peak. Then this part will be EA with catalyst, and this one without catalyst. So this part, okay, this part has a larger proportion of molecules with energy that is the same with bigger than activation energy, or the same with activation energy, and it has a lot more reactant that can successfully overcome the activation energy when the activation energy is lower because of the catalyst. And this one, it is higher temperature, it is always slightly to the right. Dihydrogen peroxide could cause further oxidation of the methanol, suggests a possible oxidation product. Methanol. Methanol is a primary alcohol. So when it is oxidized, it will produce aldehyde, which is methanol. Okay, so CH3, no, that would be H, COO, COH, and if you oxidize more, it will form methanoic acid, which is HCOOH. This one, the answer. Methanol is usually manufactured from methane in a two-stage process. Determine the overall equation for the production of methanol. As you can see here, we can eliminate this and only one H2 left, CO also, but not for the rest. So the reaction would be CH4 gas plus H2O gas will produce CH3OH liquid and H2 gas. 8 grams of methane is completely converted to methanol. Calculate to 3 significant figures the final volume of hydrogen at STP in decimeter cube. If mass is known, we can calculate mole divided by 16.05, which is molar mass of methane, and you get 0.498 mole. So to calculate volume of hydrogen, N times Vm. So for mole, as you can see, methane has the same coefficient with hydrogen. Therefore, it will have the same number of mole, which is 0.498 times 22.7 decimeter cube per mole, and this is mole. So you will get 11.3 decimeter cube. Consider the first stage of the reaction. This is the reaction. Determine the enthalpy change. Use section 11, bond enthalpy. So as always, try to draw the Lewis structure to be safe. And CO plus 3H. So you have 4CH plus 2OH, C triple bond O plus 3HH. So that would be 4 times 414 plus 2, 430 becomes 1077 plus 3, 436. That would be 2582 becomes 2385. So delta H would be 2582 minus 2385 becomes plus 197 kilojoule. State one reason why you would expect the value of delta H calculated from the delta H values given in the section 12 data booklet differ from your answer. Because bond energy, it will be always different delta HF with the delta H that is calculated through bond enthalpy, because bond energies are average value. It's not very specific to the compound. It's different with delta HF values. It's very specific to a compound. State the expression for Kc for this stage of reaction. So Kc would be, this would be product, and then this would be reactant. So Kc would be CO product and H2 to the power 3 because the coefficient is 3, and CH4 and H2O. State and explain the effect of increasing temperature on the value Kc. The reaction itself, it's CH4 plus H2O becomes CO and then 3H2. As we calculate delta H, it's positive 197 kilojoule. So forward will be endo, reverse will be exo because it's positive. Okay, so when temperature increases, Kc increases and it's forward reaction. How? These are the endothermic, so it absorbs energy. So when the temperature increases, the equilibrium will shift to the direction to take in heat, which is endothermic because the temperature increases. So that's why when the equilibrium favored to endothermic, which is right, so the product will increase. It will affect the Kc. Kc will increase as well because it is a forward reaction or shift to the product. Now consider the second stage of the reaction. CO plus 2H2 forms CH3OH. The equilibrium constant Kc has the value of 1.01 at 298 Kelvin. Calculate delta G. That would be negative RT ln K. So delta G to calculate, that would be negative 8.31 times 298 T times ln 1.01. You get negative 24.6 joule per mole or negative 0.0246 kilojoule per mole. Calculate a value for the entropy change. So delta G is known. The formula will be delta H T delta S. So delta G will be should be in kilojoule because delta H, it's known in kilojoule. This one, kilojoule, negative 129. So this will be negative 129, and this one negative 0.0246 minus 298 K times delta S. So delta S will be negative 129 plus 0.0246 divided by 298. You get negative 0.433 kilojoule per K mole or negative 433 joule per K mole. Justify the sign of delta S with reference to the equation. The equation is CO gas plus 2H2 gas produce CH3OH liquid. Entropy will increase from solid to liquid and then to gas, and it will decrease from gas turns into liquid and then to solid. The entropy will decrease, and therefore the sign of delta S is negative, as there is no mole of gas in the product, or it changes from gas to liquid. Predict giving a reason how a change in temperature from 298 K to 273 K would affect the spontaneity of the reaction. So the temperature decreases. Reaction becomes less positive as the entropy decreases. Okay, delta G, delta H minus T delta S. Okay, if negative T delta S become less positive, so delta G become less positive as well. So delta G, it means delta G is negative. So when delta G is negative, it is spontaneous. Ethanol is obtained by the hydration of ethene, C2H4. State the class of compound to which ethene belongs. Is alkene. State the molecular formula for of the next member of the homology series to which ethene belongs. Ethene is C2H4. So homology series should be plus CH2. Okay, differ by CH2. If you add CH2, that would be C3H6. So the molecular formula of the next member of the homology series of ethene, this one, C3H6. Justify why ethene has only one single signal in its H NMR spectrum. This is ethene. You can see it's symmetrical. Okay, so it because hydrogen atom in the same chemical environment, because it is symmetrical. So this is the same with this. Deduce the chemical shift of this signal. If we check on the section 27, okay, that would be 4.5 to 6 because it's alkene. So the answer will be 4.5 to 6.0. Chemical shift at 4.5 to 6 ppm. Suggest two possible products of the incomplete combustion of ethene that would not be formed by complete combustion. It will be carbon monoxide and carbon. If it's completed, it's carbon dioxide. A white solid was formed when ethene was subjected to high pressure. Deduce the type of reaction that occurred. It is a polymerization. Polymerization is a reaction because of high pressure that can force ethene molecules to undergo a reaction where they can join together to form long chains, creating polymer. Alternative synthetic routes exist to produce alcohols. Sketch the mechanisms for the reaction of propene with hydrogen bromide using curly arrow. That would be HCHH, and it will produce carbocation intermediate and Br minus will react quickly, produce addition product. So weak pi bond in the propene acts as a nucleophile, donating 2 pi electrons to an electrophile, which is H. HBr has a polar HBr bond where the H atom is an electrophilic center. A pair of electrons from the carbon double bond are used, forming a new bond with H, and Cl, Br will split. So the pi bond now is no longer exists, right? So it will form a carbocation intermediate, and Br minus will, as a nucleophile, reacts quickly with the carbocation intermediate, producing the addition product. Explain why major organic product is 2-bromopropane and not 1-bromopropane. Okay, for the 2-bromopropane, if we compare with 1-bromopropane, this one it's more stable compared to this one because it involves the formation of secondary carbocation. Secondary carbocation is more stable than primary carbocation. So secondary, if it's the C attached to 2 alkyl, but for this one attached to this one CH2, only 1 alkyl, so it's primary. If it's 2, secondary. If this one CH3, that would be tertiary. Tertiary carbocation is more stable than secondary. Secondary is more stable than primary. That's why the major organic product, the carbocation intermediate that is more stable, which is secondary compared to primary carbocation. 2-bromopropane can be converted directly to propanol. Identify the reagent required. So propane, 2-bromopropane, that it has Br and then produce all, which is OH. So this OH will replace or substitute Br. So we need NaOH or KOH as a nucleophile. Propan-2-ol can also be formed in one step from a compound containing a carbonyl group. State the name of this compound and the type of reaction that occurs. It will be propanone. Type of reaction is reduction. Propan-2-ol. Propan-2-ol, that this is a secondary alcohol. When it is oxidized, will produce ketone. So the opposite way, which is reduction, it will produce secondary alcohol, which is propanol. So propanol can also be formed in one step through a reduction reaction. When the nitrogen pentoxide, which is N2O5, is heated, the colorless gas undergoes thermal decomposition to produce brown nitrogen dioxide, so it is colored. Suggest how the extent of decomposition could be measured. You can use colorimeter meter because it absorbs the light, or you can check the change in color, or also you can check the change in volume because it produced gas, or you can check change in pressure because it produced gas. Data for the decomposition at constant temperature is given. This is the data, and this is the graph. So you need to plot missing point on the graph and draw the best fit line. So this is the missing point, which is the fifth one. So 24.30 and 0.7. So 24.30, so is around this one, 0.71. So this one. And you need to draw best fit line. You will have a ruler with you. So you just need to, it's very difficult for me to draw. So just think of this is, alright, yeah. Outline why increasing the concentration of N2O5 increases the rate of reaction. Because it has a greater frequency of collision as concentration increases. Okay, when concentration increases, of course, number of atom will increase, and then collision will be more, collision occurs more frequently, so the rate of reaction will be increased. Write the rate expression for this reaction. That will be rate K N2O5. It's the first order of reaction because this is the graph of the first order reaction. Okay. Calculate the value of the rate constant K giving its unit. K would be rate divided by concentration of N2O5. So that would be, I would choose one of them, 0.078 times 10 to the power negative 3 mole decimeter to the power negative 3 minute to the power negative 1 divided by 2.74 times 10 to the power negative 3 mole decimeter to the power negative 3. Then you will get 0.028 minute negative to the power negative 1. Because this finish, this finish, this finish, this finish. So only this. So I choose one of them. Okay, the first one. You can choose any of these 5. You will get the same answer. So that's all the explanation for the chemistry higher level paper 2 May 2021 time zone 1. If you find this video is helpful for your exam preparation or revision, please don't forget to subscribe and let your other friend knows about my channel to support me. Thank you for watching, and bye.